Yes, class. Am I audible to all of you?
Yes, ma'am.
All right, class. Uh, See, already a lot of time has been wasted. I wanted to start the class from 8:30, but because of connectivity issues, the class couldn't be started. Even the previous batch, no, that I was taking, in the middle of the class, I had to stop it. But now I think the connectivity is fine by now. Just let me know, class, in between if my voice cracks or the screen stops sharing. Because in the last class that I was taking, the previous batch which came before you, suddenly the screen stopped sharing and the voice was also breaking a lot. So just let me know. I think by now the Wi-Fi is fine, but you can just text me in between because otherwise you'll not understand this part. This is a very important topic. Relation between electric field and voltage. See, electric field lines are present, right? Electric field lines are present. Now see, when we drop a tangent on the electric field, when you drop a tangent on the electric field, then you get the direction of electric field. When you drop a tangent on the electric field line, you get the direction of electric field. This we have studied in the first chapter. All right. See, class, I have taken 2 points. This is A point, this is B point. The separation of A and B, this is dr. All right. So charge is present, Q charge is present, electric field is present. All right. Now, work done in carrying charge from A to B. What is the formula of work done? We write formula of work done as F dot S, right? Now see. So work done, how can we write it? What is the force? If a charge is present in electric field, we write the formula of force as QE. And what is the separation? What is the displacement? It is dr. So work done is QE into dr, right? This is the force, this is the displacement. So this is the formula of work done. Now class, one more formula of work done we have studied, right? We are, since we are learning this lesson, we also know one more formula of work done, that is charge into change in potential. This is the second equation, right? Work done is QEDR, work done is QDV. Can we equate both these? Because it's the same work done. So see, when we equate QEDR is equal to QDV, Q will be cancelled. So electric field will be equal to minus dV over dr. Fine. This is a very important relation, class. E is equal to minus dV over dr. This is what? Rate of change of potential. Now see, when there are two terms that you have to differentiate between, one is rate, one is gradient. Just understand these two terms because these will be repeating. Rate and gradient. See, if any quantity changes with respect to time, any quantity changes with respect to time. Like in class 11th, you must have done velocity is rate of change of displacement. Displacement is being changed with respect to time. Or you must have done acceleration. Acceleration is rate of change of velocity, change in velocity with respect to time. So for these terms, we use the term rate, something that is changing with respect to time. Current we'll be doing the next lesson. Current is rate of change of charge. Rate of change of charge. All right. When something changes with respect to position, change with respect to position. That is, can you see? Potential is being changed with respect to distance. Potential is being changed with respect to distance. So this is known as potential gradient. So what this exactly is, this is potential gradient. We call this as the potential gradient. This is written over here. E dV over dr. This is change in potential with respect to position. So if something is changing with respect to position, we put a term that is potential gradient, right? C class, if it is changing with respect to x-axis, we'll put x is equal to minus dv over dx. If it is changing with respect to y-axis, we'll put it as minus dv over dy. If it is changing with respect to z-axis, then we'll put it as minus dv over dz. Now, class, in this derivation, there wasn't any minus sign. I had added this minus sign by myself. There was nothing. See, work done is q dv. This work done is QEDR. There is no presence of a negative sign, not even an electron is being present. So how we'll put it? How did we get this negative sign? So there is a huge significance of this negative sign. This entire topic is written in your NCERT also in the form of theory. This comes a lot, class. I'll tell you. First, let us understand the significance of negative sign. Then pay attention to how this topic comes in your exam. All those students who had joined earlier, you have joined. Deborah, you were also there, no, earlier? All right. See, minus sign, the negative sign. This basically says that direction of electric field decreases. This tells about direction of electric. Okay, Deborah. Direction of electric field is there. It's a vector quantity. So how will you determine the direction of electric field? Direction of electric field is where the potential decreases, right? So this is the negative sign. This negative sign is basically telling you that wherever there is less potential, their electric field will be going. Suppose there's one point, A point is there, which is having the voltage 5 volt. B point is there having the voltage 2 volt, right? So electric field's direction will be from 5 volt to 2 volt, that is towards the right. Direction will be here. Why? Because out of 5 volt and 2 volt, where is the potential less? Potential is less over 2 volt area. Clear? So among this is the direction. This is how you have to determine the direction. Even through electric field lines, if I tell you, here if I tell you potential is very high in this region and potential is quite less in this region, so direction of electric field will be towards the negative potential, and since this is opposite, that's why we put a negative sign. Now class, remember what all things are asked as a theory part. Please read this from NCERT also, though everything is written over here, but do read it from NCERT as well, relation between electric field and potential. This is given in your second lesson of NCERT. There you will find a separate heading for this. 2 points are written. First point says that electric field's magnitude. It tells about, see, first it talks about the magnitude. So first point regarding magnitude is that electric field's magnitude is directly proportional to potential gradient. Secondly, it says that electric field's direction is where potential decreases. These 2 points are very important. Apart from this, this formula is also very helpful in your other derivations also that will be coming. This is partial differentiation. This I'll tell you. Partial derivation. This I'll tell you. But note down this first. See, class, this question says that if V is equal to KQ by X, then what is electric field? See, this is again one more derivation of electric field as well in terms of potential. What is the new formula that you've studied? This is minus dV over dx. Because position is x given, that's why I'm writing it as dx, right? This is dV over dx. Now, what is the value of potential that is given to you? E is equal to minus d over dx. What is potential given? KQ divided by x. This is the value of electric field that is given. So electric field will be equal to minus KQ will be taken common. X to the power minus 1, let's write it as. When you're differentiating this over dx. All right. Now electric field, this becomes minus KQ. How do you differentiate it? N x to the power n. This becomes equal to n x to the power n. See, x to the power n is present. So x to the power n becomes equal to nx to the power n minus 1. So what is n right now? This is minus 1, right? So minus 1 into x to the power minus 1 minus 1. Clear, class? This is how you differentiate x to the power n. What is x to the power n right now? X to the power minus 1. This becomes n for you. So that's why minus 1 instead of n. X, then what is again n minus 1 minus 1. That's why we have written it. See, E is equal to KQ x to the power minus 2. Let's bring E back. So E is equal to KQ by x squared. This was the formula also, electric field for a point charge or a sphere. So if in the derivation of electric field, it is asking using potential, derive the formula of electric field due to a point charge or sphere, then go by this method. Note it down. See class, can we discuss the next question? Anybody who has tried this? V is equal to 3x square. The next question is very easy. Everyone has to answer now. This was also not difficult. V is equal to 3x cube. Electric field, C class. If potential is given as 3x cube, electric field is minus dV over dx. So this becomes 3x cube. Minus 3 will be taken out. So this becomes, okay, this 3 will also come. 3 minus 1. That becomes minus 9x square. Now, this is the value of electric field. You have to find the value of electric field at x equal to 2 meter. Got it? Potential you had, you differentiated it, you got electric field. Now you have to find out electric field at x equal to 2 meter. So electric field will be minus 9 into 2 square. So 4 into 9, 36 minus 36 Newton per coulomb. This type of question you will find it in so many textbooks, also in your NCERT also. The next question, all of you try to answer me in the chat column. Meanwhile, first write it down, then I'll show you the question. So those who will be completing, please text me in the chat column because the question is very easy. Proper signs and units I want. Yes, class answers. It's a very, very easy question. This can be solved mentally only. Yes, Aliza, Deborah, your answers. Mariam has answered. So only Mariam has answered. Mir, Hussain, Rajita, Fadil, just based upon the direct formula. See, electric field, you have to find out electric field. You know the potential. What is the separation? The separation dr that we write is given as 10 meters. What is the potential difference given? The potential difference is given to you as 20 volt. What is the formula of electric field? Electric field is minus dV over dr. So this is minus 20 by 10. Electric field is minus 2 Newton per coulomb. So just check your calculations, Mariam, once again. Note it down, then we'll see a new topic, that is partial differentiation. Partial derivative is actually a type of differentiation only. See, now how do we do partial differentiation, derivative we do. Please understand this class carefully. This is actually part of your syllabus, but rarely you will find the questions. Moreover, the questions are from the above portion that we have discussed. But this derivation is a little different from the differentiation we have done. Right? This differentiation is different from the differentiation that we have done. Ex is equal to minus del v over del x, right? When you are differentiating x component of electric field, then y and z will act as constant terms. See, all the three are variables. All the three are variables. X square, y, z square, all are variables. When we are talking about electric field due to x, that is only the x component we are taking. So y and z will be constant. Just treat them as a number. If you have 3 in your differentiation, what you do? You bring out 3 separately. If you have 4 in your calculations, you separately bring out 4, right? That's how we differentiate. Now in partial differentiation, what all the variables will be acting as constants to you. If you're talking about x-axis, then y and z will act constant. See, suppose this is the differentiation. I am differentiating x square, y and z square. So for me, which is the constant term? Z square and y. So y, z square, I'll bring it as it is. Now differentiating x square. Differentiating x square will become 2x. So what is our answer? Minus sign. That becomes 2xy z square. First tell me. First one is clear? Then only I'll proceed towards the next. Mariam, clear? Rajita?
Yes.
Rajita, you present? Rajita Rapaka?
Yes, ma'am.
Okay. Aliza and Deborah. Fine. Now see, when we are differentiating y, then your other two variables, that is x and z, will act as constants. All right, now x and z will act as constant terms. So when we are differentiating this, x is constant. So when I'm differentiating, x square is constant to me. See, earlier it wasn't constant. I had to differentiate this. Remember? Now I am just putting this as a constant term. Z square is also acting as a constant term, right? So x square, z square is acting as a constant term. What is left now? Dy over dy is left. So my answer is minus x square, z square. In any ways, when you are differentiating y to the power 1 minus 1, that will become y to the power 0, which is equal to 1. So in any ways, you will have this answer. See the difference between partial derivation? You are partially differentiating it. In partial derivation, you're partially differentiating it. Two quantities will be acting as constant, though they are not constant terms. Right? Last one, z-axis. X square, y and z square. Now, when we are talking about z-axis, x and y will be constant. So what are we left with? X square and y. This will be constant. And what is left? Differentiation of z square. So that gives x square by z, 2z. This becomes minus. This is our answer. Now, what is the final equation? See, it says calculate electric field. What is the final equation? Let me write down the final equation. Wait. My final net answer will be Ex plus Ey plus Ez, right? What is Ex? Minus 2xyz square. Minus 2xyz square. Minus, what is y? Minus x square z square. This is I cap. This is j cap. This is minus 2x square by z k cap, right? This is my net electric field. If I have to find out electric field of E at 1, 1, 1, so put x, y, and z as 1. So net, this will become, this all is 1 minus 2i cap. This becomes minus j cap. This becomes minus 2 k cap. That's it. If you want to further find out the magnitude, you already know how to find out the magnitude of a vector quantity. This is how we perform partial differentiation class. Note it down, please. If any doubts you're having, let me know. C class, starting with electric potential energy. This I know won't be completed today. I need extra classes this week because already today we had a very disturbed schedule because of my network. So in between, I'll inform you on Thursday or on Wednesday. I'll inform. We have the group already, so I'll just get a confirmation from all of you first. Yes, cause of potential energy. Whenever you have potential energy in the system, C class, in students who were there with me in 11th, we have discussed this. But for the new students, just understand potential energy's concept. Potential in energy is not just a concept that is present because of change in position, change in shape, change in orientation, the way you have been studying in your previous classes. Potential energy means interaction, electrostatic interaction. What is electrostatic interaction? Understand the cause of potential energy. Electrical potential energy will be able to define it by yourself. Electrostatic interaction means what? Electrostatic interaction means two charges are able to exert force on each other. Right? Two charges are able to exert force on each other. If two charges are able to exert a force on each other, it means there will be a potential energy that will be exist. What is the cause of potential energy? Electrostatic interaction. Two charges are present, they are exerting forces on each other. All right, that is what is the cause of potential energy, electrostatic interaction. If a charge is present alone, the single charge is present alone, no other charge is present, then you won't have any potential energy in your system simply. See, let's talk. Let me give you the example. You must have done that lesson, gravitation. Gravitation chapter you must have done in your 11th class, first book, end lesson, chapter 8. So see, in gravitation also, two masses were present. So we had a concept when both the masses were able to exert force on each other. We had potential energy that time also. That was gravitational potential energy. Fine, that was gravitational potential energy. When two charges were present in electrostatics, they are able to exert force on each other using Coulomb's law. So we have electrostatic potential energy this time, electric potential energy. Right. So depending upon different types of interactions, you have to have the potential energy in your system. Electric potential energy is what? Electric potential energy is the work done by external force in carrying charges from infinity to their respective position. Understand this definition. Details, don't worry, I'll do it in the next class. We'll be taking extra classes this week because the syllabus is lagging behind. I wanted to take an extra class on Friday as well, but there was so much confusion regarding the revision test and some students were having exam. That's why I couldn't occur. But let's see this weekend because otherwise the syllabus will be very slow. We have to at least reach magnetism quickly. All right. Though current electricity is not a lengthy lesson, let's complete capacitance and start with current electricity by this week only. Okay, yes, electric potential energy is the work done by, yes, work done, the concept of work done. All the entire work that is being done gets stored in the form of potential energy. It gets stored in the form of potential energy. So potential energy is nothing but work done. Work done. This lesson is entirely based upon work done and integration. That's why in this beginning only I'd asked you all to revise integration and come. Fine. So work done by external force in carrying charges from infinity. Infinity means what? A point which is so much far away that no forces are acting on that. Infinity, you already know what is the meaning of infinity. Counting is infinite. 1, 2, 3, 4, 5, 6. You can count up to infinity. Infinity means something that you're not able to count. But what is meant by when I say a charge is brought from infinity? When I say a charge is brought from infinity, this means that something somewhere where no other charges are able to exert force on each other. It's isolated system. Net force is also zero. That is infinity. To a point where forces can also be exerted, where electrostatic interactions can be present, where electric potential energy can be generated, where electric field can exist, electric potential can exist, Coulomb's law will be applicable. To a certain point. All right. So electric potential energy is the work done by external force. What is meant by external force? See, the area under consideration is called system. Suppose I am investigating a glass, I am doing an experiment with a glass of water that is kept on a table. Some experiment I am doing. So that glass of water and table, that becomes a system for me. Normal reaction will occur in the glass because of the contact force, gravitational force will be acting downwards. But these forces are acting in the glass only, within the system. So these are internal forces. Clear class? What I'm trying to tell you, there is a glass that is kept on a table. Fine. This is my area. This is I'm investigating this glass that is filled with water. I'm investigating this and including the table. So a normal reaction will occur because of contact. Gravitational force will occur because of the weight, right? Some other force might occur and all. So this is my system right now. This is my system. Any force that is acting within this, that is known as the internal force. Suppose I have just exerted, I have just pushed the glass. I have myself, by my hand, I've pushed the glass and the glass has filled and the water has filled up. This force that acted because of my hand was not a part of the system. That was a part of surrounding. So my hand is exerting a force. This force is now called external force. That is what is meant by external force over here. So what is, again, last time I'm repeating, what is electrical potential energy? Firstly, it will come due to interaction. Whatever is the number of interactions, start counting them. Electric potential energy is the work done by external force in carrying charges from infinity to their respective position. Note down this. Text me done once completed. All right. If you people have written it till here, you can leave the meeting. In the extra class, the next weekend, we'll complete this lesson quickly so that we can complete current electricity also fast. Please revise and come. I'll start with electric potential energy. Thank you so much, class.